In this video, I want to go over some of the assembly and nesting features in Mastercam 2022. If you have a CNC router, pay attention. And even if you don't, this is some cool and underutilized functionality that you will likely be able to use at some point. For this example, I'll use this exhibit that we designed and built here at Mastercam for the American Precision Museum in Vermont, USA. The museum centers around the history of manufacturing and is housed in an 1800s factory that was formerly powered by a 6-meter water wheel. That's over 18 feet in diameter. This museum tells the story of the American system for manufacturing and the role it played in influencing manufacturing worldwide. This exhibit is manufactured almost completely from pre-finished plywood, with the exception of the aluminum gear train, purchased hardware, and the plaque. There are two different types of plywood used in this structure: a dark walnut for the wheel, and a lighter maple that makes up the base structure. Let's look at the easiest way in Mastercam 2022 to program and cut this project. I'll start with the maple components, shutting off the hardware on level 3 and the walnut components on level 1. If this was one or two parts, it would be simple to use dynamic transform and manually manipulate and nest the parts in the proper plane orientation to get ready for programming. However, when it comes to a complex, multi-component assembly, that would not be efficient or properly optimize raw material. Imagine trying to move all the individual components for a set of kitchen cabinets. Instead, let's look at Mastercam's automated nesting abilities. Navigate to the Transform tab and launch the Geometry Nesting command. On the Sheet tab, I can define my sheet size. I'm going to use standard plywood at 4 foot by 8 foot or 2440 by 1220 millimeters. This will be 19 millimeters thick, or nominally 3/4 of an inch. I'll want to make sure that I allow Mastercam to create as many sheets as necessary. With this project, I am less concerned with the grain direction versus making sure I optimize the sheets, so I'll leave this set to ignore. I'll also leave 100 millimeters between the sheets. I don't want the tool to cut right at the edge of the sheet in case there's some misalignment at the machine, so I will leave a 3 millimeter sheet margin. All components were designed narrow enough to account for this. We'll navigate over to the Parts tab, and this is where I'll specify the geometry I want to nest. Right-clicking in the parts list, I'm presented with a lot of different options. Not that we will be using it on this assembly, as it's made up of all solids, but new for Mastercam 2022 is full mesh support in nesting. I'll click Disassemble Solid and select the entire structure. After a few seconds, this will bring up the nesting dialog again. As part of the design, each one of these components was labeled in the Solids Manager, and those labels come through when nesting. Since they are available, I'll add those part labels at 25 millimeters in height so I can identify parts quickly when programming. As I plan to cut the components with an 8 millimeter downcut tool, I will need some part-to-part distance. 10 millimeters should be sufficient to ensure that I'm not running the tool down a common edge with a climb cut on one side and a conventional on the other. With all settings addressed, I'll click OK. As it calculates, I get a report here of all the nesting results, showing the various sheets and the utilization of material. When satisfied, click OK. The components are optimized in such a way that it uses the least amount of material possible. In this case, nesting was able to fit all the components on just 4 sheets with room to spare. Without any input from the programmer, nesting was also intelligent enough to figure out which way to face each component. Notice that all dados and rabbets are face up, making this a single-sided operation. Navigating to the Plane Manager, you'll see that it also located the first sheet right on the top plane 0 point, ready for programming. Turning on translucency, we see that each component is labeled, and in case a component requires a special process when programming, it is easily identifiable. In fact, if this was a hidden structure, those names could even be quickly engraved into the surface for ease of identification and assembly. Since this is all exposed and pre-finished ply, I'm not going to do that on this project. Now would be a good time to repeat this process with the walnut sheets. At this point, that should be a straightforward and repetitive process. The disassemble and nesting functionality isn't new to Mastercam, but it is underutilized, especially among those not running a router. Even if I were not cutting wood every day, there are lots of odd jobs where this could prove useful with a typical metal cutting CNC. I hope you found this video enlightening, and be sure to check out the video where I cover the programming aspect of this job and show some of the new Mastercam 2022 contour functionality.